Hi everyone. Today we are going to solve another Leetcode problem, which is remove duplicates from sorted arrays. So if we are given an array of integer, um, which is sorted in non-decreasing order, we have to remove the duplicates in place. So we cannot really have any additional memory like a temporary variable. I cannot use that to remove the duplicates. So let's look an example to understand, what exactly they're asking for. So for example, if my input nums is 112, then my output should be 2. That is telling them that, only two elements are unique, and my nums should be 1 comma 2. So anything after that, it doesn't really matter. It can be anything. But yes, my first two elements should be the unique elements. So this is a very easy problem to solve, although it looks difficult because we are used to using a temporary variable. So let's just first look at the intuition as to how we can solve this problem, and then we'll come back to the solution. So for easier purposes, I've already written the list over here. So for example, if this is the list and we want to remove the duplicate elements from this list. Now let's take an element which is I. So let's always start I from this, from the ne next to the first element. And I'll tell you the reason why I'm doing that. And I'll also have another pointer which is going to be L, which is always pointing to the element. So basically anything below of L will always be unique. So anything under like 0 over here is unique in itself. So always the first element is going to be unique. That's the reason why we have kept L over here. So the reason why I've kept I at not at the first position and the next position is because I is an element where I want to compare that to the previous element if it's unique or not. The reason why I'm keeping it at this position and not starting from this is because, if I do I plus 1, when I reach over here, there is nothing to compare, right? So I go out of bounds, I go out of index. And that's the reason why I want to start from the position which is beginning next to the first one. So what I do over here is basically I just compare I, is it equal to I minus 1. So if this condition is true, then I just increment I by 1. So I will be equal to I plus 1. And if this condition is not true, so that means the element that I'm seeing is a unique element, that's when I will share the steps that what we will do. So let's start over here. So basically it will compare I is equal to I minus 1. So is 0 equal to 0. So this condition is true, right? So it will just increment I to the next element. Now if we see these two are not equal. So what happens? I'm going to replace basically this element with where my L pointer is. So essentially what I'm going to do is I'm going to erase 0 out, and I'm going to replace that with 1. So this element I'm going to write over here, and L pointer I'm going to add to the next position, and my I also moves to the next position to compare. Now if you look that anything below L, again 0 and 1 are unique elements. So I can simply return 2 because I have two unique elements. Now if you look at my list, right, now it will compare 1 with, and again it will compare 1 and 1. So now these two are same. So this condition is true. It's going to move I to the next pointer. Again, it's going to do the same thing. Is I equal to I minus 1? Yes, so it's going to cross this out, move I to the next position. Now is I equal to I minus 1? No, we have a new unique element. So again what it's going to do? It's going to replace 2 with where my L pointer is. So I'm going to erase 0 out, erase this 1, and I'm going to replace that with 2. And I'm going to move my L to the next position because anything below L is unique. Now I have 3 unique elements and I will move to the next position. So now again it's going to compare. Is it same? Yes. So it's going to cross out and move ahead. And now again it's going to compare. Now it's not unique. So 2 and 3 are different. So this condition becomes false. So essentially wherever my L pointer is, I'm going to just replace that with wherever my the element of the I pointer. So I'm going to erase this and I'm going to replace this by 3. And I'm going to increment I by 1 and I'm also going to increment L by 1. Now again this is looking, so 3 and 3 are same. So it's going to move I to the next position. Now this is 3 and 4 are not same. So the same process wherever my L pointer is, I'm just going to erase that element and I'm going to replace that with whatever my I value is. So it's 4. And now again, I cannot go any further. So I come out of the loop. So I'm going to return and increment L by 1. So I'm going to return the value of L, which in this case is 5. So I have 5 unique elements. And basically anything after this, right? Remember, you have to have the unique list, but after that, nothing matters. It can be anything. So basically anything after 5 is completely fine with. So now let's look at the coding part for this. Let's look at how we can code this problem in an easier way. So first step I think is for us to check if the array or list that is given to us, if that is null, then we can simply return 0 because there are no unique elements in it because it's null. The next step, as I mentioned, right, that we want L as a pointer to be equal to 1 because anything below L is all the unique elements. So first element will always be unique. Now let's put a for loop over the list, and as I mentioned, I'm going to start that from the first position so that I can compare I with I minus 1s because I don't want to go out of bounds. Till the last element. Now, as I mentioned, I'm going to check if nums of I is equal to nums of I minus 1. If this is the case, basically I'm going to check if it's not equal, probably. That would be easier. So if it is not equal, then what do I have to do? Basically, wherever L is, I have to replace that with nums of I. And I have to increment L with 1. If this is not the case, then I will obviously move to the next pointer and L is something that I don't want to move. And in the end, I'm going to just return L. Now let's run this code. Let's submit it. So as you can see, it beats 72%. So this is a pretty good solution. Thanks for watching.